Okay, this problem, when you begin one of these problems, the first thing you want to do is look at your list of techniques here. So we notice the first thing, change everything into sines and cosines. So we can do that. We can change this by using these identities over here. But besides that, we also want to see if there's another identity we can apply. Now if we change this over into cosine over sine, we're then going to have two different fractions. So then I want to go down and look at number 3. We want to get common denominators if there's fractions. This part looks like something that you could factor, but again, factoring is not really going to work in this case to cancel something out. You want to go for the techniques that are going to allow you to actually go through and show that one side equals the other through simplification. So we know that we're going to use the first technique, and we're also going to use the third technique there. So the first thing we're going to do is apply the identities to each of these guys here. So cotangent is the same thing as cosine theta over sine theta. Now I'm probably going to have to get common denominators here because I have two fractions. So I'm going to leave a space there. And over here I have the rest of it. 2 cosine squared theta, and then sine theta, cosine theta down here. And then this one, I'm going to go ahead and change that by using this identity right here, sine theta over cosine theta. And so now I've already done the first technique, change everything into sines and cosines. The other strategy we talked about was that you want to, if you have two different fractions, you want to change these into common denominators. Okay, well our common denominator here is going to be sine theta times cosine theta. So a question you might be thinking is, can I just multiply both sides by the common denominator to clear out all the fractions? The answer to that is going to be no. And the reason why you're not allowed to do that is because, as I mentioned in a previous video, this equal sign right here, we haven't yet established that this is really an identity. So because we don't know it's an identity, we can't do the same thing to both sides of the equation like a traditional equation. We can't multiply both sides by something, cross multiply, subtract. We can't do any of that sort of thing on this. So even though algebraically it might work out, we can't do that just for the fact of we don't know initially if that really is an identity or not. So because of that, we're going to keep on one side, we're going to work one side all the way down until we have one side equal to the other one. So we're only going to work on the left-hand side. So because of that, we want to get both of these to have the same denominator. So we're going to multiply this one by cosine because that's what it's missing in order for us to have a common denominator. So I'll multiply this by cosine theta over cosine theta. So now that I have common denominators, I can go ahead and write them as one fraction on the bottom. So I'll combine these together as one single fraction. And when I multiply that across the top, I get cosine squared theta. And then the rest of it I'm not going to do anything with, so I'm just going to go ahead and carry it down. Okay. Well, what I notice now is, but when I did that step, by adding this together for one denominator, one fraction, I now have some things I can combine together. I have like terms now. So when I rewrite this, the 1, I don't have anything to combine with that. I'll just leave that as a 1. But then I have a 1 cosine minus 2 cosine squared. That's going to give me a minus 1 cosine squared theta. So now my problem can be rewritten as this. Still, the right-hand side again comes down through all your steps. Okay, we've already done two different techniques. I could do a factoring technique on this, 1 plus sine, 1 plus cosine, 1 minus cosine, but that's not going to cancel anything out in the bottom, so that's not the right technique I want to use. And so if you get to a point where you don't know what to do next, again, you want to start looking at your list of identities because that means that you probably need to put an identity in here to take the problem down further. In this case, 1 minus cosine squared is this one right here off my list of identities. That's sine squared equals 1 minus cosine squared. So I'm going to replace the 1 minus cosine squared with this particular identity here. And that's going to be sine squared theta. And the bottom I have sine theta, cosine theta. And then over here, again, I have the same thing. What will happen here is you've got two signs on the top and you have one sign on the bottom. You can cancel one of those out. And then what happens is you get this as a result. You get sine theta over cosine equals sine theta over cosine. You want to go ahead and get down to this last step. So again, this is not your final answer. Your answer is actually all this work to show that you've got from one side to the other.